Hello everyone. Um, Today's we're going to be looking at physical science chemistry paper 2 Mpumalanga June 2023 paper, and our focus will only be on organic chemistry, uh, questions from 1.1 to 1.4, and question 2, the whole of question 2, which is nomenclature and all of that. So now let's have a look at our first um, questions in the multiple choice questions. Uh, Multiple choice question. I would like to run them by explaining first before selecting an answer. Now, in 1.1, they ask you, what do we call a specific group of atoms within a molecule which is responsible for the characteristic chemical reactions of that molecule? Now, first you're given four options, and out of those four options, there's 50% chance of two answers to be totally wrong and 50% chance two answers to be one of the correct ones. So you look at an isomer. What is an isomer? Compound with the same molecular formula but different. There is nothing being said about that. So definitely, let me put a red. A um, A is gonna be out. No, that's black. And then you look at a homologous. I don't know why I always say it's homologous. It's homologous series, which is a series of organic compound that can be described by the same general formula, or which one member differs from the next with the CH2 group. And there's nothing being said about that. So definitely that is not the right answer. Then you look at a hydrocarbon. That is a compound containing carbon and hydrogen only in their main structure. Still doesn't explain that. So you have 75% of the answers, and definitely a functional group, as would be explained as per exam guideline, is definitely a group of atoms or bonds in a molecule that are responsible for the characteristics of a chemical reaction of that molecule. So our correct answer here would be functional group. Right. Now we have again 1.2, the IUPAC name of an organic compound with the molecular formula C5H12O, and you are being given A, B, C, and D. First, what do you need to identify? I would say, given an IUPAC name, well, you want to give an IUPAC name from a molecular formula. Well, this molecular formula looks something to me like it comes from a C and H2 and plus 1, O plus 2, if you can say, and then with an O. And what homologous series has that type of a general formula? And the answer to that would be, this is an alcohol. It has the same, well, it doesn't have the same, it has a similar general formula as an alkane, but it has an O as an extra atom. And the only one that would simply be the closest to correct is this alcohol, which is option A. Forgot to change that black. Now, for one to say this is pentanoic acid, let's try and see pentanoic acid. What does it have? Maybe drawing A, B, and C and D easily um, would easily show us the difference here. So we have pentan 1-ol, which is what? Let's make it white. Pentan 1-ol would be this with its hydrogens here. Pentan 1-ol, and then everything H, H, H. Please excuse my H's here. H, H, and H. That'll be pentan 1-ol, and the ol is in the first carbon. Then you look at B, which is pentanoic acid. With pentanoic acid, you're looking at 1, 2, 3, 4, 5, C double bond O, O, H. Now, remember, the molecular formula given was a C5H12O. Now, we're having already in pentanoic acid 2 oxygen. That is why we take it out. Then, if we look at the third option is what? Ethyl propanoate. Now, ethyl propanoate comes from a what? Comes from an ester. Ethyl meaning this alkyl substituent or alkyl group comes from ethanol, and then propanoate is C double bond O and the CH3 and CH2. Our molecular formula still here, C5, 1, 2, 3, 4, 5. There are 5 years, but our hydrogens are now 10, so that also takes us out. And the last option, it's a 3-methyl butanol. 3-methyl butanol. How does 3-methyl butanol look like? Now, this would be 3-methyl butanol. Butanol, first things first, is an aldehyde, so it means it has a C double bond O at the first carbon. 3-methyl, this would be the third one. Okay, now let's check the number of H's that we'll have here. You'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, which doesn't make that 12. So definitely the first option goes as the correct one. Okay, now let's get back to our multiple choice here. I might need to move you. Okay. Consider the two organic compounds represented by Roman figure 1, Roman figure 2 as shown below. Okay, Roman figure 1, we see this structure here, and Roman figure 2, we see that structure there. Which one of the following correctly represents the homologous series to which each belong? Now, compound Roman figure 1 has this type of a homologous series with a C double bond O bonded to a C and bonded to a C, and we should all know that that is a ketone. So either option B or D are correct depending on what number 2 is or Roman figure 2 is. And Roman figure 2 is just a C double bond O that is bonded to an H and another H, but the functional group here is just being bonded to an H and either an alkyl substituent or, and we all know that is an aldehyde, so it's not an alcohol because we've already excluded A and C. Therefore, the answer right here would be D. Okay, I think we need to attach our second picture here. From 1.4, let us try and stretch that out. Wasn't aware of that update. Still need to learn more on using this. Okay, now this is our 1.4. Now in 1.4 we have a flow diagram which normally appears in question 4. Now these are conversions from a general formula CnH to N, and CnH to N is a general formula for alkenes. Now this alkene undergoes a reaction and becomes an alcohol, and this alkene undergoes a reaction and becomes a CnH to N plus 2, which is a alkene. Right, now this is an alkene. We'll take a little bit of an example here and say, hey, my favorite alkene, how about if you react with an inorganic reactant to make an alcohol? To make an alcohol, you need an OH group and a hydrogen from an alkene. And the only way you can get that is by adding water. Then the water will take the H to here and the OH to there. Since this molecule can just rotate, then it will make us an alcohol. And you work this reaction up with some H plus proton from sulfuric acid. Right. Then that means the inorganic reactant X would be B or D. Now, to make an alkene to become an alkane, it's an addition reaction. Now I need to draw this one outside of this. If you want to make an alkene, you must add what? Hydrogen, which goes under the presence of a catalyst platinum or Raney nickel. But in here we're only given platinum. So therefore the correct answer for in here would be option B. This one here. I know I said this question is going to be mainly focused on organic chemistry, but Let's look at a 1 point. Can I have an eraser first? 1.5, real quick. Now, the rate of a chemical reaction increases when the surface area of a reactant is increased. Well, that's a factual statement. This change in the rate is due to the option 1, increase in the density of the reactant particles. Now, density is what? Mass over volume. Then we move. Increase in the concentration of the reactant. You're only increasing the surface area. There is no concentration increase there. We move. Increasing the exposure of more reactant particles to a possible collisions. Well, that is one of the things that increases the chemical reaction's rate. Then the altercation of electrical conductivity of the reactant particles. We don't know whether these particles react with have electrical conductivity. So the most correct answer here would be a C. Now why C? The simple example of taking a Panado tablet and a grandpa powdered. Which one gets to work fast? Even in the advert, well, this is not an advert for grandpa, but grandpa powder gets to work fast, which means it has an increase in exposure of more reacted particles to possible collisions, which means it heals you faster than just taking Adcod or Panado tablet. My apologies to those companies. I'm not trying to promote or trash. Okay, now let's move on to our question 2, which is a little bit long. The whole of question 2 looks like this. This attachment is going to be the end of me. Now we must move this one down and down and down and down, and we expand it. My apologies for that, but we're still learning to use these things. Okay, now the picture looks blurry now. Let me just take it a little bit down. Yeah, looks better now. Okay, define. Well, this question had a little bit of a mix up with some Afrikaans here. Define the term homologous series. Now, as per exam guideline, homologous series, I do not like writing down definitions, so I always advise students to look for their exam guidelines either online, or we'll attach it as part of our YouTube video. But the description given from the exam guideline is that a homologous series is a series of organic compounds that can be described by the same general formula, or which one member differs from the next with a CH2 group. Right. Then we look at 2.2.1. Let's see. 2.2.1. What is there in 2.2.1? Write down the letters that represent the following. A ketone. How do we see a ketone? Either by a C double bond O that is bonded to two carbons, Do we see any structure like that here? Nope. Or we see it with suffix own because it's a ketone, and we see that number or alphabet H is a ketone. And how do we see a halo alkane at 2.2.2? Haloalkane. Haloalkane is an alkane that is attached with a halogen in its parent structure, with the halogen as a substituent. Then by just looking here, out of these 8 organic compounds, we can see that F is our haloalkane. Then we move up to 2.3.1. 2.3.1, well, I think I'd have to move this picture a little bit down. Okay, let's move it a little bit down. Okay, 2.3.1 says consider compound A. Now, compound A has a semi-condensed structure, and it's not easy to get an IUPAC name for a semi-condensed structure. Now, what do we do in that case? We have to draw the structure. Structure has a CH3 with a CH attached to a CH3. Apologize for not putting the H's on time. Then there is a CH, a double bond, and a CH, and a C attached to a methyl group, and another methyl group, and another methyl last group. Now let's fill in our H's. Right, I think we have all of them in there. Okay, they want the IUPAC name. To do an IUPAC name, you must first number your carbons. First of all, this structure is an alkene. And where is this alkene? Right here. And you can definitely see that this would be carbon 1, 2, 3, 4, 5, 6. Either you're starting from here, it's the 1, or here it's the 1. Okay, so it means the double bond is in carbon number 3. Let's try a different color. Let's say carbon number 1, 2, 3, 4, 5, and it has 6. So either this can be 6 or that can be 6. Or this can either be 1 as well. So now, those two names you can give the structure. And those two names would include, can you take this? A little bit down. No, just to the side. Alright, two names for this structure would be, if we choose the red, the blue. Okay, let's start with the red. If we choose the red, going from carbon number 1 here, our substituent is here, and the next two substituents would be here and here. So that would make the structure a 2, 5, 5, and after a comma here, that would be what? A trimethyl. Remember, it's an alkene, so it's a hex. Position what? 3 in. Oh, if we choose to go with the blue numbering, our substituents would be here and here, and lastly would be here. So that gives us a 1, 2. So this is 2, the first substituent, and a 2, and the last substituent is a 5. And all of them are what? Are 3, which is trimethyl hex 3-ene. The correct IUPAC name would be this one. And one would ask, why is the 2.5.5 not? I mean, the structure has more substituents closest to the carbon that carbon number 3 having that functional group. I think that's a pretty much simpler explanation. Okay, now let's take you down. For 2.3.2, considering compound A, still on compound A, which is this one here. Well, just a few seconds to look at it. Right. Is compound A saturated or unsaturated compound? We said compound A, you can see it here, it has a double bond, and all compounds with double bonds are called what? Unsaturated. My handwriting is becoming much more like a doctor here. So it's what? Unsaturated compound. Why is it an unsaturated compound? Because it consists of a multiple bond in the carbon chain. All right. Write down the general formula of the homologous series to which it belongs to. General formula of the homologous series to which compound A belongs to. Compound A is a alkene. General formula for alkene, it's a CnH2n. Well, last but not least is 2.4. Now in 2.4 they are asking us to write the structural formula for compound B. Let's take down our O. Let's attach a new picture. They want compound B, which is what? A 5-ethyl 2.2. So it's a what? It's a 5-ethyl 2.2 dimethyl hept. Dimethyl hept. Hept what? Hept 3yn or hept 3-ine. Hept 3-ine. Oh, there's an E there. Hept 3-ine. Right. Now we need to draw the structure of this one. First, we'll look at this. Parent chain. It's hept, so it means it has how many carbons? 7. 1, 2, 3, 4, 5, 6, 7. Right. Hept 3-wine or hept 3-ine. That comes from alkynes. Where is this alkyne in carbon number 3? So either choose from right to left or left to right. So I'll choose left to right to make this ine. Alkynes have a triple bond, so this is carbon number 1, 2, and 3. And in carbon number 3, we have a triple bond. Okay, we're done with that. Now there is a dimethyl. Where is this dimethyl? In carbon number 2, we said this is 1 and this is 2. So this means we need to attach 2 methyl groups. Making our 2.2 dimethyl. And then there is a 5-ethyl. So in here it means it's just a CH3. So attach the hydrogens. These guys don't have the ones in between the triple bond. They don't have any extra because they're already bonded to 4. And then in here, carbon. Let's count carbons: 1, 2, 3, 4, and 5. In carbon number 5, we have an ethyl group. An ethyl group is the one that has an ethyl group is the one that has 2 carbons. And then the rest would be hydrogens. Right. Functional structural formula for a functional isomer of compound C. Let's take this down. Functional isomer of compound C. Now compound C is a compound C is a aldehyde, and its functional isomer is, let's call it Fi. It's a ketone. So this is butanol. So the only ketone that can be a functional isomer of butanol is C double bond O, C, H here, H, 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 H. And let's count the carbons, the carbons. 1, 2, 3, 4. And then we have 1, 2, 3, 4 in carbon, in compound C. And then the hydrogens here, it's 1, 2, 3, 4, 5, 6, 7, 8. And here it's 1, 2, 3, 4, 6, 7, 8. Then there's a double bond. Oh, there you have it. And 2.4.3, the functional group of compound G. What is compound G? Compound G is a C2H5OH. But they want what? The functional group. Can you see the functional group there? Not quite. So it's best to first try and draw the structure. So he's drawing a C2H5, 1, 2, 3, 4, 5, and then there is an O, and then H. What are they looking for? The structural formula of the functional group of compound G. So a functional group of an alcohol would be either R, or H, or just a C, O, H. But this one is just hanging like this, as you can see. Right. Now, I think we need to check our question if it's finishing. That will be 2.4. 2.5. There's 2.5. That will be page number 8. Always must go and fetch this somewhere. Let's take it down. Let's take it down. Okay. Compound D. Compound D. Is compound D a primary, secondary, or tertiary alcohol? Give a reason for your answer. Taking us back here. Compound D is a condensed. Now we need to draw this one. We need to draw this compound D. And take this one down as well. My apologies for that. I didn't know of this update, but it's technology. Right. Is compound D a primary, secondary, or tertiary alcohol? Give a reason for your answer. Right. There is D. Let's try and redraw compound D. So compound D would look something like this. It's a CH3. Attached to a C. It's attached to an H. And that's attached to a CH3, and that's attached to a CH, that's attached to a OH, and that is attached to a CH3. Okay, now where is this OH situated? Because the question is asking us situated here. Now the carbon containing the OH is attached to two other carbons, and I always use this example. If you're looking at primary, secondary, and tertiary alcohols, when you're in primary, you only have like a birth certificate, and then when you get to secondary, you get your matric certificate, and then in tertiary, you get your degree or diploma or higher education certificate. So you have three. So now, this one, the carbon attached to the hydroxyl or OH group is attached to two other carbons, so that makes it what? Secondary. And that would be our reason and our choice of the answer. So it's a secondary alcohol, and the reason being is that the carbon attached to the OH is attached to two other carbons. Then 2.6, compound E reacts with compound G in an acid catalyzed reaction. Compound E is here as an carboxylic acid, and compound G, we threw it was ethanol. So reaction between ethanol and carboxylic acid, we know it as a 2.6.1 is the reaction. Give the IUPAC name of compound E. You know ethanol. I always say the alkyl always comes from the alcohol. So 2.6.2 will be ethyl. Then what carboxylic acid do we have here? It's 1, 2, 3, which makes it propanoic acid. Ethyl propanoate. Okay, then they want the structural formula of the organic compound formed. Now we need to draw this structure. Of ethyl propanoate. Ethyl propanoate. Let's see. Ethyl. So it's coming from the alcohol. It's just gonna have its O because the hydrogen was removed for it, and that is O bonded to the propanoate is the one that comes from the carboxylic acid. So this is it. And I think we are done with question 1.1 to 1.4 and question 2 of our nomenclature. And thank you so much, guys. Please keep on watching and liking and sharing our videos. Take care and good luck for the final exam for the grade 12s. Those who are in grade 11, just keep watching this for you to get to know organic chemistry in grade 12. Thank you.